This is Josh White with JW Math Tutoring, and today's video is going to focus on the SAT math strategy of picking numbers, or as it's sometimes called, choosing numbers. So I'm going to show you how you can use this strategy to answer questions in a quicker and more efficient manner on math problems on the SAT, including on both the no calculator and calculator sections. If you like this video, please click the like button. Of course, subscribe to my channel and also sign up for notifications so you can find out whenever I post new material. I'm going to have a lot more SAT math related material posted in the coming weeks and coming months. But with that being said, let's go ahead and get to it.
But life is a dream the calculus could never predict.
So now let's go ahead and take a look at the strategy of picking numbers and see how it actually works to help you solve some problems. So first you might be wondering, what is picking numbers and why would you use this strategy? So picking numbers, or it's also known as choosing numbers, is basically a strategy to use for multiple choice math questions where you select some numbers for the different variables or different quantities mentioned in a problem. Then you work out the problem based off those numbers that you've chosen, and you use that to determine what the correct answer is. Now, picking numbers can also actually be used on problems where you are not given the answer choices as well in some situations. Why would you want to use it? Well, there's many reasons. First of all, it can be quicker to use this strategy than solving a problem, the traditional way, the way that you're typically taught to do it. Second of all, it can be easier to use this strategy of picking numbers rather than solving it the traditional way. And a third reason why you might want to use it is because maybe you don't know or don't remember how to solve the problem, in the traditional or typical way, that you might be taught, in your math class at school. Now, what types of problems are you going to look for to use this strategy? So there's a couple clues or a couple kind of keywords that you can look for in problems to determine that picking numbers would be a good strategy. The first thing is, if you have a problem that's talking about a change in some type of quantity, so maybe something is doubling or increasing by X percent or decreasing by Y percent, but it doesn't mention starting or ending values, or also the change in the quantity is not mentioned with a specific value. So like I said, it might say something increases by X percent or decreases by Y percent instead of, increases by 20% or decreases by 15%. So when you see something like that, that's a good hint, that's a good clue that picking numbers would be a good strategy to use. Another common situation when picking numbers is a good strategy is when you see questions that have answer choices which are formulas. So the answer choices are all things with either one letter or possibly more than one letter in them. And it could be equations or it could just be expressions. Another possible scenario where picking numbers tends to be a good strategy is when the question gives information about one or more variables. Things like C must be a positive number, or given that R is greater than S, or something like that, where it's telling you something about, a variable, but it's not giving you a specific value for it. That's another clue, that's another hint that picking numbers is a good strategy to use. Now, the next question, well, how does it work? So we're going to take a look at some example problems coming up, from previously released SAT exams. But just keep in mind a couple things before we get to those. First of all, you want to pick numbers that are easy to work with, especially if it's on the no calculator section where you have to do all the arithmetic either in your head or, by hand on paper. So 100 or 10 are very good, numbers to pick in a lot of situations. Also, be aware that 0 is a lot of times not a good number to pick because anything times 0 is equal to 0, regardless of what the number that you're multiplying it by it is. So generally you want to try to avoid 0 if possible, although you may have to use it in some situations. Now, if you go through the strategy of picking numbers and it turns out that more than one answer is correct, then you're going to have to repeat the process with a new set of numbers and kind of go through the whole situation again, but hopefully only have to check 2 answer choices instead of, 4. And another thing to keep in mind is, so you want to pick numbers based on the information in the problem, and so that means it might be positive or negative or fractions or decimals and so on. You don't just want to only assume, small positive numbers. Now, I mean, a lot of problems will work out nicely like that, but there might be some where you might need to check a negative number, or you might need to check a fraction, decimal, and so on. All right, so now we're going to go ahead and take a look at some example problems. This first one is from the May 2022 QAS. It's from section 3, the no calculator section. It's problem number 6. And here you're just given a basic formula, y equals x plus w over z. And they want to know basically what this formula is equal to if you solve it for x. Now, this in and of itself, doing it the traditional way, is not, a particularly difficult or time-consuming problem, but I just wanted to show this as an example of a problem where you could use picking numbers to figure this out, especially if you have formulas that are a lot more difficult than the one we're looking at here. So what I would do if I was using picking numbers is I'd start off and I'd say, okay, maybe x is equal to 2, w is equal to 4, and I'll just let z equal to 1. So now I take all those and I plug them in. Okay, so y is going to equal 2 plus 4 divided by 1. Therefore, y is going to equal 6 over 1, or 6. So now we would go down through the answer choices, and we would plug in y, z, and w on the right side, and then we would see which one of these answer choices is going to equal 2. Okay, because x is equal to 2. So for answer choice A, we have y times z, 6 times 1, and then minus 4. So 6 times 1 is 6, 6 minus 4 is 2. So far that one checks. That could be the correct answer, but we want to check the others just to be sure. Letter B, we've got 6 times 1 plus 4. That's going to be 10. That is not the correct answer, so we can eliminate it. For letter C, we've got z, which is 6, over w, which is 4, and y, which is 6. And actually, sorry, correction. This should be 1 on top. Z is 1. Z is not 6. Y is 6. So this one is just 1 over 24. That is obviously not equal to 2. And now for the last one, y, which is 6, goes on top, and on the bottom we have z times w. Z is 1, w is 4, and we get 6 over 4, or 3 halves. Again, obviously not 2. So the correct answer for this one's going to be letter A. And again, the basic strategy is I picked numbers for x and w and z that were pretty easy to work with. I used those to calculate y, and then once I had x, w, y, and z, I went to the answer choices, I plugged those values in, just did the basic calculations, and saw which of these equations basically made sense or was true. The next example problem is from practice test 9. It's from section 4, the calculator section. It's problem number 25. And here you're basically just told that the sine of some angle is equal to some value a, some variable, and you want to know which of the other following 4 statements must be true. So this, if you don't know, say the properties relating sine and cosine, can easily be done on the calculator just by picking a number. So I'll just pick, whatever, a random angle. Let's say x equals, 20 degrees. Okay, so first thing I'm just going to double check is that my calculator's in degree mode, and it is. So now if I do the sine of 20 degrees, okay, that just comes out to 0.342 approximately. So now I'll just go down through, double check all these answer choices, and one of the statements should be true and the other 3 should be false. So first, what is the cosine of 20 degrees? Is it 0.342? Nope, it is not, so eliminate choice A. Next, what is the sine of 90 minus 20 degrees? Now, you could just put this in as sine of 70, but, do the 90 minus 20 just in your head first. Okay, notice we get the same answer, which is not equal to 0.342, so get rid of that. Now we have the cosine of 90 minus 20, or in other words, the cosine of 70. Okay, it looks like that gives us the right answer. So far, it's looking like answer choice C, but we'll check D just to be correct. So now we have the sine of x squared, so we have the sine of 20 squared, or technically it's the sine of 400 degrees. Okay, that gives us 0.6428, blah, 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 blah. Now, notice that's supposed to be equal to a squared. So really what I want to do now is I want to take the value of sine 20 that I got originally, and I could just type in 0.342, but I'll just type in the expression sine 20. So I want to take that and I want to square that whole number. Okay, we can clearly see now that these two numbers on the screen are not equal. In other words, the sine of 20 squared does not equal the sine of 20 quantity squared. So D is wrong, and therefore the correct answer is going to be letter C. Cos of 90 minus x is equal to the value of A. And again, I just picked a value for x. Then I worked out what the value of A had to be, and then just checked that against all the possible answer choices to see which statement was true. Now we have an example problem from, again, the May 2022 QAS. It's from section 4 of the calculator section. It is problem number 24. And for this problem, we're going to use, again, the same strategy of picking numbers. And what we're going to do is we're going to first pick a number for t, which will be a number of years. Then we'll find the corresponding value of m for what that would be in months. And then we'll plug t into the original equation, get a value, and then we'll plug m into all these answer choices and get values, and hopefully only one of them will match. So what I mean by that is, let's say I'm going to let t equal 2. So 2 years, I want to find the value of this antique dresser. So first thing I'm going to do is I'm just going to go on the calculator. I'm going to type in 1,000, okay, times 1.05, and then to the second power. So I'll square that. Okay, I get 1102.5. So that's the value that I'm looking to match when I plug in basically the value that we're going to have to use for m down here in the answer choices. So if t is 2, meaning 2 years, then m will have to equal 24, because 24 months is the equivalent of 2 years. We just take 2 multiplied by 12, because there's 12 months in a year, and that gives us m equals 24. So now I'm just going to go through the answer choices. I'm going to plug them all in where m is 24, and only one of them is going to come out to 1102.5. So for the first one, I've got 1,000 divided by 12. I'll put that in a parentheses, and then that's multiplied by 1.05 to the 24th power, since m is 24. Okay, that's, let's see, 268.75 something, so that answer is incorrect. Second answer choice, now I have 1,000 times 1.05 divided by 12, and then raised again to the m power, so to the 24th power. Okay, that is some fantastically small number, so that's obviously not the correct answer. Now we'll check answer choice C. So here we've got, again, 1,000 times 1.05. And now this is raised to the, and I'm going to put this just in parentheses because it's technically a fraction. It is m divided by 12, so it's 24 divided by 12. And now I'll hit enter. Okay, notice that gives me 1102.5. So this is most likely the correct answer, but I'll just double check answer choice D just to be sure. So I've got 1000 and then times 1.05 to the, and now up here I have 12 times m, which is 24. Okay, that's some extremely large number. That's obviously not the correct answer. So correct answer is just answer choice C. And again, all I did for this problem was I picked a value or number for t. Based on that, I found the corresponding value of what m had to equal. And then I plugged t into the original equation. I plugged m into all of the answer choices, and I found the answer choice that gave me the same value, the same number, as when I plugged the t value in to the original equation. Now, we have another example problem here. This is from the October 2021 QAS from the calculator section. It's problem number 23. This one is a little bit more complicated, but it's actually not too bad. So you're told that one of these functions basically will have some random point on it, whatever, a comma b, and additionally, it will have a point on it where you add 1 to the x value, but it ends up multiplying then the b value by 1/3, or the y coordinate value by 1/3. So what I'm going to do is I'm going to pick a value for a, and then that's going to give me a value for b. And then what I'm going to do is I'm going to find what a plus 1 and what 1/3 b would equal. And then once I have those new points, I'm going to see which of those are on the graphs as well. So it's a little confusing, but once you see what I'm actually doing, get the hang of it, it's actually not going to be too difficult at all. So for the first thing, what I'm going to do is I'm going to let my a, or my x coordinate of my original point, equal to, let's say, 0. Okay, so now I go through all of these possible function answer choices, and I'm just going to plug in 0. And so that's going to give me b values for all of these. So I'm just going to make a little chart here, a and b. So my a is 0, and when I plug in 0 here, this whole thing becomes 1, and this b becomes 1/3. Okay, and then for this one, when I plug in 0, this whole expression with the exponent becomes 1, and then that becomes 12. And then down here, it also becomes 0, 12, and then also down here, 12 to the 0 is just 1, so it's 0, okay, 1/3. So these are my original point values. Now I'm going to find a plus 1 comma 1/3 b, and then what I'm going to do is I'm going to plug in the a plus 1, whatever that number is, to each function, and I'm going to see if the output, or my y value, matches my 1/3 b value in this column. So now a plus 1 is obviously just 1 for all of these. I just take 0 and add 1 to it. Okay, so now what I'm going to do is I'm going to just take the b values from the original point. I'm just going to multiply it by 1/3. So this 1/3 here times 1/3 is 1/9. 12 times 1/3 is 4. 12 times 1/3 is 4. And 1/3 times 1/3 is 1/9. So again, all I did is I basically took my original a that I picked and I added 1 to it, and then I took what the output was based on that a, or my b, and I multiplied it by 1/3. So these are the points that should be on the graph, but these points, only one of these is actually going to be on the graph of these 4 answer choices. And the way I figure that out is I now take my a plus 1 value, or I take my 1, and I plug it in to all 4 answer choices. So in other words, I take this first answer choice and I evaluate it for x equals 1. So it's 1/3 times 1/12, and that just gives me 1/36. So in other words, when a is 1 for this function, the y coordinate, or the y output, is 1/36. That is not equal to 1/3 of the original b value. In other words, 1/36 does not equal 1/9. That's what I'm looking to match. For the second answer choice, I just take 1, I plug it in, and I get 12 times 1/3 to the first, which is 12 times 1/3, or 4. Notice that does match, so this is possibly the answer choice. Then for C, I take 1, I plug it in, I get 12 times 3 to the first, which is just 12 times 3, or 36. 36 does not match 4. This one is wrong. And for answer choice D, I take 1, I plug it in, I get 1/3 times 12 to the first. That is 1/3 of 12, which is just 4. 4 does not match 1/9, so it's wrong. Therefore, the correct answer choice for this one is letter B. Again, just to briefly walk you through the steps that I went through on this problem, I first chose a value for A. I let A equal 0. Based on that value, I then calculated the value for B for all of these answer choices. In other words, I plugged in 0 to each answer choice and said, okay, B has to equal this number for these various functions. Then I found A plus 1 by just adding 1 to 0 for all of them. Then I found what 1/3 of B is. In other words, for my original point, I took its y coordinate and just multiplied them all by 1/3. Because to meet the conditions of the problem, this a plus 1 comma 1/3 b point must be on the actual graph. And lastly, I took the a plus 1 number, which was just 1, I plugged that into each function, and then I evaluated to see, okay, which of these outputs, which of these y values matches what it has to be, or the 1/3 b, based on the problem. And only answer choice B gives me the same number as when I multiply 1/3 times the original B value. Now, the last example here is from the October 2021 QAS. It's from section 4, calculator section. It's problem number 29. And basically, here what you have is just a single number. It's being decreased by some percentage, and it tells you that the value you get after the decrease is just x, and then it wants to know what's the original number equal to in terms of x. So, easiest way to do this one is start with easy number to work with, like say 100. Okay, so if you decrease 100 by 45%, well, just like you're multiplying 100 by 0.45, which is 45, and then you just subtract it from it. Okay, therefore, the final value would be 55. So in this hypothetical scenario, my original number is 100, my starting, or you could say my starting value, and my resulting value, or my x, is equal to 55. So now, all these answer choices are the value of the original quantity. So all I'm going to do is I'm going to plug in 55 for x in each of them. And the answer I'm looking to get as my output is, again, the original quantity, which is the 100. So I'll start with answer choice A. And we just take 55 divided by 0.45. Okay, that's 122 point something, so that is wrong. Then the next one, we're going to take 55 divided by 0.55. That is 100. This one could be the correct answer, so we keep it. Next, we do 55 divided by 1.45. Okay, that's 37 point something. Clearly not correct. Last one, divided by now 1.55. You can probably tell it's going to be an even smaller number. Yep, 35, which is obviously not equal to 100. So the only correct answer is basically right here, letter B. Again, all I did on this problem is I picked an original starting number, original quantity. I decreased that number by 45%. That gave me the the resulting value, or what the new value was, and then I just took that new value, plugged it into my answer choices, and saw which answer choice equaled the original starting value that I chose. So a couple things just to be aware of regarding picking numbers. So first of all, it's obviously not going to be able to solve, all problems that you would counter on the math sections of the SAT. It probably won't even be able to solve, most problems that you come across, in the math sections of the SAT. Instead, you should think of this as, one tool in your toolbox as you're going through looking at problems and trying to identify, the different ways that can be solved. So this is like one method you can use that can, possibly help you solve some problems, in a quick and efficient manner. Or when you maybe don't know how to solve it, again, the traditional way. So if you're taking a practice test, you're taking an official test, you may only use it, 2, maybe 3, 4, or 5 times over an entire test. But it is something that could help you answer maybe a couple of questions correctly that either you otherwise wouldn't know how to do, or could help you answer them, like I said previously, in a quicker and more efficient manner. Which will allow you to obviously save time, for other questions down the road. Now, if you like this video, of course, please click the like button on it and go ahead and subscribe to my channel and sign up for notifications as well. Continue to have more SAT related math content coming up in the future. And now, just coming up here on the screen momentarily are more example problems that you can practice the strategy of picking numbers on. These problems will also be listed in the description of the video as well. Otherwise, if you have comments about anything covered in this video, please feel free to leave them down below. Here are the practice problems for you to be able to do further examples on the strategy of picking numbers. These will also, like I said, be posted in the description below with basically a link to a PDF file where page 1 of it is just what you see on the screen with the test that it's from, section, the problem number, and then on page 2 it will also have the answers to these problems as well. So feel free to use these to get more practice on the strategy of picking numbers.